We're working on electrons. That's what this unit's all about. Electrons and how they are and where they are and what's about them. Last time you worked on POGL, which is that where you worked with the dorm and the people in the bunk up and down. Remember that? Okay. And you should have got sort of an idea of where we're headed. With this POGL, we were able to take your brain and say, okay, treat it like a dorm. And we were having those people in the dorm be like our electrons. So it's going to feel sort of like what you did there. Make sure to upload that. It is uploaded to the thing. Today we're going to talk about exactly how they work in the actual words. So just go out in the main hall and go one door this way. Okay. We're going to show how they actually work. Now, these are some fancy names. Orbital notation, electron configuration, noble gas configuration. You're going to know how to do that by the end of the day. And it's not hard, okay, as long as you stay with me. The first thing we're going to do is we're going to make our maps. So please, make sure you have your periodic table out in front of you. Please, listen. So your green paper you don't need yet. Put it away or put it off to the side. Put it on your computer. Put it off to the side, whatever. If you get done before everybody else gets done, work on your quizzes, okay? So have your periodic table or not your computer or your phone out ready to do quizzes. But you're working with me. The first things that we're going to use on your periodic table are going to use your colored pencils. And we're just going to outline. What are we going to do? Outline. Okay, that does not mean fill in. Okay, I had people last period that when I said outline, they filled in. We're going to fill in with other things later. So you're going to use pencils for the first part. I will let you know when we move to the crayons. So do not use crayons right now. Use what? Color pencils. Okay, here we go. So on the first one, we're going to just outline these big areas. These big areas have to do with metals, nonmetals, and metalloids. You are going to make a key at the top. I don't care if you use blue or purple. To me, it's purple. Okay, I would probably use purple. So I'm going to put, of course up here I don't have purple as one of the choices. So I would have put purple and metals up at the top. And then I would outline the metal area. I would not do each individual one. And there's a reason why later. So just be okay with that. So just quickly outline. You're also going to outline these bottom two. Okay, we're just outlining. Then I would go and grab a reddish orange if you have one. So not a red, but a reddish orange, something off red because we're going to use red later. But I'm going to put red up here because that's all the color I have. So something that's just off red, not red because we're going to use red later. Okay, and we're going to do the metalloids. And you're just going to outline them. Now, if you notice, it is a staircase right here. It's a staircase till you get to astatine, and then you start coming up the backside, but you include two extras, which are germanium and antimony. Those are your metalloids. Then you're going to grab a green. And again, we're just outlining non-metals this time. I'm putting a key as I'm doing this. Grabbing my green, and I'm outlining the green. And I'm just outlining. And hydrogen can play both games. It can play both the non-metal and the metal games. So it's sort of its own beast. Okay? So this is all we've done. We've just outlined the metals and the non-metals. That is it. Okay, I'm going to give you a few seconds to catch up with me. If you haven't, it's not going perfectly. You just want to quickly outline. Quickly outline. Okay, quickly outline. It's not... Yep, you're going to bring in Tennessee in. Oh. Yes. Yes, the bottom two rows on the periodic table are included. That's why I sort of made that blue at the bottom. Okay, so that blue or purple, whatever you used, is also going to be around those bottom two rows that aren't shown on this. The reds are the nonmetals, the boron, silicon, arsenic, tellurium, astatine, antimony, and germanium. Okay, we got to be quick. I'll give you one more minute, and then we're moving on. As I said, you got to just be quick. We're just outlining. It can't be, if you're one of these OCD people, you're going to have to redo it. I'm just telling you right now. Because I'm not going to give you time to do it perfectly. I just want the outline. Just the outline. Okay, 30 seconds. Make sure you've got the outline down. We're just doing a quick. If you're OCD, I told you I'm sorry. Get one and then you'll have another one to do later. Okay, if you haven't got it, you're going to have to get it from a neighbor. I am going to put this up on your canvas, so if you got behind and you want to go back, you can go back and you can pause it. Amazing thing. You know, I'll put a video up, you watch it, you can pause it. Okay, we're going forward. I want you to grab 2 colors. I don't care what 2 colors on your colored pencils, but 2 colors you have not used. You have not used. 2 new colors. We're going to just mark the liquids and the gases, but we're going to either use stars or circle or some kind of thing. So for instance, on my gas, if I wanted my gas to be, and like I have very limited colors up here, so mine's going to be green. So if my liquids, if I said this green asterisk is my liquids, I'm going to mark the 2 liquids on the periodic table, which are mercury and bromine. And then maybe I'm grabbing another color, like blue, and I'm going to say this little circle means that it's a gas, like a gas bubble. And I'm going to put a little circle on everything that's a gas. Just a little circle on that color over in the corner, just so that I know that that's a gas.
Which one's the top one?
Liquid. So we're just doing, the orange ones on here are liquid, and the yellow ones are gas, but we are not coloring them in, right? We're just marking them with an asterisk or a little circle, or you want to do a square or a triangle, whatever, okay? Or you want to do asterisks, different colors, that's fine too. But you're just marking on your periodic table which ones are liquids and which ones are gas.
So the yellow ones are gas.
The yellow ones are gas. Everything else is solid. Everything else on the periodic table is solid. So while you're doing this, I'm going to talk to you a little bit about what we had on the last one, which was metals, nonmetals, and metalloids. You guys have experienced metals. Tell me how you know something is a metal. Shiny. Yep. Okay, it's shiny. How else do you know? How else do you know it's a metal? It's shiny. Okay, most of them are pretty solid. The exception to that's mercury, which is also known as quicksilver, and it's a liquid and it moves. And the other ones are the first column, because I can actually cut those with a knife. Just a regular butter knife. They will cut. Okay, so they're not really solid. They're solid, but not really. Okay, that's some good ones so far. What else do metals do for us? Give me some properties. What things do metals have that other things don't have? We use them in the kitchen. Why do we use them in the kitchen? They conduct heat, right? They conduct heat. We use them in the walls. Why do we use them in the walls? They conduct electricity, and they can also be used as structural. Yes. So they conduct heat and electricity. They're used for structures a lot of times to make things stronger. They are what we call ductile. That's a new word, ductile. What do you think that means? Ducks. What are ducks? Things that go quack, quack. No, yes, what? Okay, so water can affect it because if you look at iron, it actually rusts, but some it doesn't, right? Gold doesn't have much of an effect. Okay, ductile means I can pull it into wires. So if metals are ductile, so I can pull them into wires. So ductile, pull into wires. The other thing is, another word, new word, is malleable. Does anybody know what malleable means? It is. It is the ability to bend something or smash something or form it into something. So malleable means I can make it something new by just hammering or pounding it. Okay? So all this has to do with metals. Okay, now let's go on the other side. Your metals were most of the periodic table, which is basically the blue area here, with the exception of few blue on the right. Then you had that section in the center, that red area, that was the metalloids. Why do you think we call them metalloids? They're kind of like metals. They have some of the properties of metals. So instead of being good conductors, they're semiconductors. And they're semi-insulators. They are in between metals and nonmetals. Okay, tell me what you know about nonmetals. Those are on the upper side of that staircase. So we got carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, phosphorus, silicon, selenium, and the noble gases. What do you know about nonmetals? If it's not a metal and it's a nonmetal, give me some properties that it would have. Yes? Rubbery. It could be, yes, because sulfur can be made into rubber for the tires, yeah. What else? What happens if I hammer it? What do you think is going to happen? It's actually going to crumble. Okay, so if you hammer a clod of sulfur that hasn't been vulcanized to make it into tires, if I hammer it, it actually shatters. So think of a salt crystal and you hammer it. It just falls apart. That's what nonmetals do. They just crumble. Okay, they are insulators. They stop electricity. They stop heat from going through them. Okay, so now we got sort of the idea. What's a metal? What's a nonmetal? What's a metalloid? Right? Everybody got all this done so far. Okay, we're going to move to the next one. This is where you use your crayons. Grab your crayons. 4 colors. Nope, fibbed. Okay, on this one, I need you to grab your green packet and open it up to the back of the green page. So the blank green page. So you have the back of the green page that's written on. I want you just to make a quick, and I do mean quick. So if I was doing it myself on the paper, I would just go, okay, here's the first column, here's the second column, here's that middle section, here's 6 more columns on the end. 1, 2, 3, 4, 5, the last one's bigger, and 2 across the bottom. You just need to know the names. Okay, so quickly draw you a beautiful periodic table like mine. You can probably do it better. And I do it sideways because I have more room that way, but you can do it however you want. And we just need to put the names down. Now, on the top of this, I can put the families of the periodic table. Then I don't have to write family after each name because I know they're all families. Families are sort of like groups that hang together on the periodic table. They're sort of like the gangs of the periodic table. They have the same kind of properties. They can do the same kind of things. They react the same with other things. Okay, the first column is known as the alkali metal family. So that first column on the left is the alkali metal family. This family right here starts with lithium and goes down to francium. We really don't include hydrogen because hydrogen bounces back and forth between the alkali family and the halogen family on the other side of the periodic table. But this alkali family does not like water. You put them in water and they get very violent. Lithium's probably the most calm of the bunch. You put it in water, it just sort of bubbles and fuzzes. You put sodium in water, and it starts to bubble and fizz a little bit more and gives you a little bit of yellow flame, and then it'll finally go out. Potassium in water, you get a purple flame, you get sparks, you get a big bang. You put rubidium in water, you've got a bang. Okay, it's going to be a good-sized boom. If you put cesium, just a tiny little speck of cesium, in a bathtub of water, it will blow the bathtub of water up and leave a crater. Very, very reactive in water. Okay? YouTube it. They've got a YouTube that shows all of those on it. Just say reaction of sodium or cesium with water. Yep. Okay? The next column over is the alkali earth metals, sometimes called the alkaline earth metals. This one is sort of reactive with water. They'll react with water, but they're more calm about it. It just sort of, they sort of melt into it, no big deal. You probably have experienced this if you have hard water, you get calcium deposits or hard water deposits. They sort of fall out of water. They're sort of in and out of water, not a big deal. This big section in the center that's 10 across and is sort of sunken is known as the transition metal family. This group of metals just sort of hangs out, just doesn't really do much of anything. It sort of is determined by who it reacts with. Underneath the table is known as the lanthanide series and the actinide series. These two series are very important in our technology advances in the last few years, on our cell phones, on our computers, on everything like that. These are very, very important. In fact, some of them we didn't even know that they were 2 and 3 elements till just lately because their properties were so similar we couldn't separate them. So these are where we're getting all the advances. And in the future years, maybe 113 through 118 will be where we get our new advances. Because when I was going through high school, they just found this bottom area, and now they're using them to do all kinds of cool stuff. Okay? The first family in the next block that goes up is called the boron family. Well, it starts with boron. That's easy. Okay? It's the boron family. It, is sort of boring. It does soap. It has aluminum. It has gallium that can be heated up a little bit and acts like mercury. It has thallium, which is a rat killer. It's a very diverse family, but it's sort of boring. Carbon family's next. Again, starts with carbon. Carbon is its own little beast. It can go with the nonmetals and it can go with the metals. It's sort of the mediator of the periodic table because it can go with either or and get along well with either family, either side of the periodic table. Next one is the nitrogen family. Again, starting with nitrogen. Way easy to remember. Nitrogen's family is explosive. This is where we get our explosives, our matches. It also very poisonous. This is arsenic and antimony. These are things that can kill you. And then there's bismuth. And, that one is the calming member of the family. It soothes your tummy issues with Pepto-Bismol. Okay? Then we have oxygen's family. And we know oxygen. We get along with oxygen and helps us breathe. But the one down below it, the sister sulfur, is a little bit stinky. Haha. This is where we get rotten egg gas. Okay? Then we get halogens. And we're going to do a lab where we experience halogens. And we actually get to put electricity through them and they'll light up. You've heard of neon lights. You've seen neon lights, right? This is our halogens. Okay? The next column is our noble gases, and we're going to be using them a lot. Everybody wants to be like a noble gas because noble gases are cool. They're the cool kids at school, and everybody wants to be like them. Okay, so they are the noble gases. They have it all. Everybody wants to be like them. All right, has everybody got this down? Yes? I gave you enough time talking, yakking. Good. Okay, next one. Now the crayons. Now back to your periodic table. I need you to get those 4 colors out. I don't care if you use blue or purple on the bottom. Your choice. Okay? I want you to color that. Just shade it really lightly. Do not shade it dark. Just shade it really lightly and quickly because I'm going to add some more things to it. I'm going to give you about 3 minutes to shade these areas. That's it. 3 minutes to shade these areas. So do it quickly and lightly. Quickly and lightly. Notice that helium is yellow. You might want to push that first. Helium needs to be yellow. So try and keep the same colors that I'm doing up there because as we talk about it, I'll be referring to the colors too. So hopefully that you can look and see what I'm doing. Okay, what? Okay, quickly as you can, get it shaded, even if you can outline and shade, and then you can finish the center. We got 1 more minute left. So like I said, just quickly shade. Quickly shade. I told you this would drive you nuts if you were OCD, because I'm going to make you do it quickly. Because crayons color that area faster. You don't have to use crayons if you don't want to. You could use colored pencils. Like I said again, though, if you are falling behind a little bit, this will be up on your canvas. Okay, 30 more seconds, and you're with me with a black pencil or with a regular pencil or a pen, because we're going to add some things to this. I also want you, whatever color you added this down here, okay, whatever color you had down here, I also want you to color at least part of this over here with that color so you remember to go down, because that's what it's telling you is to go down. And a lot of kids forget to go down. So just take part of it right next to the yellow, and if it was purple, I would color this little area purple. If it was blue, I would color it blue. So I remember to go down. Okay, leave the other half of it blank because we're going to add something to it, though. So purple, just this right here. Okay, here we go. Ready? Got your black pen or pencil. Here we go. Down the side. Starting here. 1, 2, 3, 4, 5, 6, 7. Okay. In here, where the green starts, I'm going to go 3, 4, 5, 6. Where my purple or blue is, I'm going to go 4, 5. That's a funky 5, but that's what it is. Okay, right at the beginning of the red, I'm going to go 2, 3, 4, 5, 6, 7.
Wait, are we like numbering them?
Yep. Okay, on top of the yellow area, I want you to go S equals 1 and draw your best imitation of a sphere. That's my best imitation of a sphere. I am not an artist. I will let you know that up front. So I'm going to tell you what I'm drawing along with drawing it, because you might not know what it is if I don't. Yours looks like an egg. Okay, above the green area, I want you to put D equals 5. 4 equals a clover leaf. 1 equals a donut with a balloon coming up the top and out the bottom. So this right here basically is a donut with a balloon coming out the top and out the bottom. Sort of like a binky, yeah. So 1 equals the donut with the balloon on the top and the bottom. Okay, above the red, you're going to go P equals 3, and you're going to do a dumbbell shape or an infinity shape, but you're going to show that it is a three-dimensional being, like two balloons next to each other. Okay, so two balloons hooked is the best way to describe it. They look like what?
Cat eyes.
Cat eyes. Oh, okay. All right. Have we got all that down? Okay, now we're back to your green sheet. We're going to talk about some things in your green sheet. Now, keep this out. If you've got your computer, just put it up on your computer and use your green sheet for a minute. We're going on the first page of your green notes. Now we've got our map. Our periodic table has now become our map. Okay? We're not going to add anything else to it at this point. So if you wanted to laminate the whole thing, you could. If you don't laminate, at least go around the edges with tape. Because what I found is we're going to be using this so much now that it gets worn out. And people have pieces of periodic table they're trying to keep together in their folders. So please go at least around the edge with tape. All right, so here we go. Basically, what we're going to be talking about is how electrons go into each area. When you did the POGL, it talked about the sunny room and the pink room. Remember that? And the sunny room could only have 2 people in it because it was only one room. but the pink side had 3 rooms, and you could put 2 in each room, right? Well, this is what's happening here. This is the sunny room, the S. It can have 2 electrons in it. The pink room is the red or light pink, because when we shaded it would have gone light pink, right? The pink room would be over here. It's 6 across. It has 3 rooms. The D in the middle section has 5 rooms and can have 10 in it. And the F down here has 7 rooms or 14 total electrons that it can have. So as we go through, basically, remember I told you to put a little bit of whatever color you used for the F down at the bottom, whether it be blue or purple, so that you would know that it came up here. It actually is supposed to insert right here between the S and the D area. Okay? But if we did that, the periodic table with letters, numbers would be so small we'd have a hard time reading it. So that's why they do that little insert. So, as you're looking, it says underneath, we're working with, this is off-bound. We'll talk about off-bound in just a minute. But underneath where this little thing is, the off-bound triad is what it's called, is how many electrons. Can you see where I'm at? How many electrons, can you see that, does each orbital have? So let's talk about the S for a minute. S was what shape? Sphere. Sphere. How many orbits did it have? I want you to put this down too in there. How many orbits? How many rooms? 1 room. 1 room. 1 orbit. So put 1 orbit. How many electrons can each orbit hold? 2. How many people can be in each bedroom? 2. So put 2 electrons. Okay, now the pink or the P room. How many orbits are in the P? 3. Okay, so 3 orbits in the P. Each orbit holds how many? 2. Good. So 2 times 3 is 6 electrons can be in the P. Now, looking at your chart again, the D is that center sunken area. How many did I say D equals? 5. So there's 5 orbits in the D. So that means how many total electrons? 10. Good. All we have to do is times them by 2. Okay, what about the F? That's down on the bottom, that blue or purple that you colored. I hear 6, I hear 4. Is that what number I told you to write there? Or did, oh, I didn't tell you to write a number there. Oh, count how many across. How many across is there? 14. Divide by 2 is? 7. So put F equals 7 there. I forgot to put F there. F equals 7. So on that bottom part, I'm going to just really quickly go back real fast. This should have been F equals 7. And we're not going to worry about the shape of that because it's too many weird, funky things. Okay, so we can have 14 electrons in that. Now, we're going to go through the rules. And I'm going to have you tell me back in your own words. So the first rule was Aufbau. I went past it. Aufbau's rule basically says fill the lowest shell first and then work up to the highest energy. Okay, what does Aufbau say? Right. So write it down. Aufbau's principle is basically fill the lower energy shells first, then go up to the higher energies. And it's a triad. Notice it's not straight. Okay, it's zigzaggy. It's going to fill some 3 levels before it fills 4 and 5, but it'll fill some 4 levels before it fills some of the 3. So it's sort of zigzaggy. We color-coded our periodic table so we could figure out how Aufbau's filling. Okay? Second one. So Aufbau's principle, fill the lowest energy shell first. Hans, this was everybody gets their own room and at that level until it's full, then you have to go back and pair. Okay, so put it in your own words. I put it up here, but basically everybody gets their own room, or everybody gets their own orbit, every electron gets their own orbit at that same level until all the rooms are full, then you got to go back and share it. Okay? So however you want to put it in your own words. You're going to tell these back to me in a minute. So make sure you're writing something down. To share or not to share a bedroom, it's not even a question, is it? Right? And the last one is Pauli's. You're supposed to be putting it in your own words, though. Okay? So Hund, everybody gets their own room until all the rooms are full, then I got to pair up. Okay, Pauli. Poly was, do I get the top bunk or the bottom bunk? So basically it says, I'm going to put a positive spin in each orbit first. The second spin has to be a negative spin. Okay, so they have to be opposite spins. I can't put 2 on the top bunk or 2 on the bottom bunk. One's got to be on the top, one's got to be on the bottom. Okay? All right, don't lose track of those because we're going to come back and talk about them. Okay, so as we're looking at the orbits, this really quickly shows you the S and the P. The S was a sphere, right? And this is just on the second level out. So the S was a sphere. The P's were like 2 balloons next to each other. You don't have this picture. Just stay with me for a minute. The P's were like 2 balloons hooked together. But remember from math, there's 3 axes. There, the X, the Y, and the Z coming out at you. Those balloons are on each of those axes. So first they're on the X, then they're on the Y, then they're on the Z coming out. So as I fill that 1 room, 2 room, 3 room, this is the X room, the Y room, the Z room of the P. Okay? They're all different shaped orbits. Okay? So, tell me real quickly, what is Pauli's rule? Somebody brave. Yes? Okay, opposite spins, positive first. Good. Somebody tell me what Hun's rule is. Somebody new. Can't have the same person. What's Hun's rule?
It's like you put each electron in one orbit and then go back.
So there has to be 1 in each orbit of the same level, and then I can go back and pair it. So I can't pair them up to start with. They've got to each have their own room first, and then go back and pair it. Good. Let's see. Can you explain off-boss for me?
Why would you choose me?
Just because.
I may be falling asleep, but you gotta fill all the lowest shells first.
Right. So you got to start always from the bottom up. So as I'm building something, I don't start from the top down, right? I always start from the bottom up. So remember that. Okay, so we're going to do what's called orbital notation. We're going to put those arrows in representing electrons. We're going to show each room as we go through. So here is my periodic table that I've colored off to the side, and my numbers are off a little bit, so we'll on that first column, so we'll have to deal with it. But we're going to find helium. So everybody put your finger on helium. This is one of probably the easiest ones to do. So helium. How many protons does helium have? 2. So by the end, we should have 2 arrows. That's it. So I start always at number 1, hydrogen. It is on the first row, and it's going through the S block. So I would put 1 S, and I put 1 room. Okay? I've got to get through hydrogen to get to helium, right? So I'm going to put 1 arrow in for hydrogen and 1 in for helium. And I don't have to go past the 1s, right? I'm still in the 1s. I'm done. That's it. That's the orbital notation. I don't have to show the rest of this. This doesn't have to be shown. I just did a copy and paste so I could have it for all of them. Okay? So I'm going to be doing a few extras to show you, so stay with me up here and just sort of watch for a minute, and then we'll do some practice on your paper. I know some of you are going, I can't find this one, I can't find this one. I want your attention up here, so hopefully by the time we get to where you're writing, you understand it. Does that make sense? So you just want your periodic table and you want to be able to put your finger on it. Okay? So oxygen, find oxygen. Okay, how many should I have by the time I'm done with oxygen? 8, good. So we're always starting up here at the top with hydrogen. So I'm always starting right here in the 1s. So I would draw 1s and I would put 1 line. Then I know I'm going to go through hydrogen and through helium. So that's 2 arrows in the 1s. By the time I get done there, I'm now at number 3. I'm on the second row. I'm still in the S. So I would write 2 and an S, so I would write this part, okay? And then, am I going to make it all the way through the 2S? Yeah, I'm going to put lithium and barium in. I'm still not there. So I'm going to put lithium and beryllium in. Now I go across the table to number 5, which is boron. It's in the 2P. So this is where I would write 2p, and I would write 3 lines above the 2p, representing the 3 rooms in 2p. Okay? I'm going to go how many into 2p? Nope. 1, 2, 3, 4 to get to oxygen, right? Count them. Count them. 1, 2, 3, 4, right? So I'm going to go 1, 2, 3, 4. Done. I don't have to write this other part. Like I said, I did a copy and paste. Okay? So as I'm doing it, I'm writing down what's going in. Okay, find silicon. It's also in the pink area. Did you find it? Right here? Number 14. So we should have how many arrows? 14. So again, starting at the top, if I do what I did with oxygen, I'm going to be past oxygen, right? So it's going to be just like oxygen. So I'm going to get up to where oxygen was. Okay, here's oxygen. Now I'm going past oxygen to fluorine and neon. Can you see where I'm at? I'm right here at neon. Now I follow the numbers down. I go to number 11, and that's the 3s. So that's when I just do, ignore this little blue squiggly. It'd just be one line, okay, through the 3s. And I would put in 1 for sodium and 1 for magnesium. That would take me to here. I go across. I now hit aluminum, which is on the 3p. So on the 3p again, I should have 3 lines for 3p. And I go 1. How far in? 2. Now, do you remember a special thing that happened on your POGL when you had an empty room and they were about the same level as the P and the S? What happened? Something happened there. Do you remember? I have this empty room right here. And it's almost the same level, right? It was just a half a step down for 3s, right? Because I have that empty room, and carbon is the only row that does this. Because I have that empty room, that one actually bumps up to that empty room and moves up right there. Hey, I got my own room. There was only one left, and nobody else is coming. So I get my own room. By doing that, it opens up the ability to bond with 4 different things and make itself complete in the outer shell. So carbon's column is the one that does that. So if you want to just put a little note on the side there for you that carbon's column is what we call, it will hybridize. What will it do? Hybridize. And what does hybridize mean? That's a fancy word. What did I just tell you it did? It stole one from the S and put it in the P. Okay? So basically that S1 got to go up and get its own room. Okay, now let's try and find one in the F, or then the D. Fe. Fe is right here in the middle of the green area, or the D. So basically I'm going to do the same thing. I'm going to get all the way to silicon, because we were at silicon. So I'm going to get all the way the same as silicon. But I'm not going to hybridize because I'm still going past it, right? So I'm going to go all the way through the 3p. Whoops, let me change colors back again. All the way through the 3p. So I'm going to fill the 3p. When I get to the end of the 3p, I'm now coming down to the 4th level, which is potassium, right? And it's in the S again, so it's only going to have one room. So that's where I get this 4s. Okay, I'm going to fill it up by putting potassium and calcium. And then I go through that and I get to the 3D. And D had 5 rooms. So I'm going to have 5 open spaces. How far do I need to get in to get to iron? 6. Okay, so 1, 2, 3, 4, 5. Come back 6 and I'm done. Okay, can you see how this is working? Okay, let's see if we can do it without the little help behind. So, boron. Where's boron? This is in your notes now.
Right there,
5. So it's right there. So I'm going to have a total of 5 arrows. What's the first orbit I get to? 1s. So I got, right, 1s, I put a line. And I'm going to put how many arrows on that line? 2. How are they facing? Up first and then down. I like to use half arrows because I'm lazy and I don't want to have to draw the other side of the arrow. You can do that too. Okay, and then now I'm at helium and I'm going back down to lithium. What do I write next? Second row, I hit the S. How many rooms in the S? 1. Okay, how many am I going to put arrow-wise in the S? Well, I've gone here, right? I'm coming here. I'm going to go 1, 2 through. 1 up, 1 down. Okay, I'm still not to boron, so I got to come clear across here, and I hit the 3 or the 2p. 2p has how many rooms? 3. 1, 2, 3. I have to show all the rooms, even though I'm not using them. How many into the 2p do I get? 1. And I'm done. Okay, let's do cobalt. Cobalt is right here. We got to start it the same way, right? Up at the top, follow your finger through. I'm one of these ones that if I follow the finger through with the numbers, I'll never go wrong because I have to pass the numbers. So starting at the top, I'm going to hit the 1s. I'm going to go hydrogen, helium. Then I hit the 2s. It also has 1 orbit. I'm going to hit lithium, beryllium. Then I hit the 2p. 2p has 3 rooms. I'm going to go boron, carbon, nitrogen, oxygen, fluorine, neon. I'm still not there. So I've now gone to the end of this row, and I'm coming back, and I'm right here. So I'm going to hit the what row next? Or what? 3s. Good. And there's how many orbits? 1. And I'm going to put 1 up for sodium and 1 down for manganese. I'm now here. I'm coming across right to here. What am I going to hit next? 3p. Good. How many rooms? How many orbits? 3. Am I going to go all the way through it to get to cobalt? I am. And there's how many all the way through? 6. So I'm going to put 6 arrows in 3p. 1, 2, 3, 4, 5, 6. What do I hit next? 4s. Good. So 4s comes next. How many orbits are in the 4s? 1. How many am I going to go through? 2, right? Potassium and calcium. I'm now at number 20 going on to number 21. What happens at 21? Where am I? 3D. How many rooms or orbits are there in the 3D? D equals what? 5. So I'm going to have 5 rooms. 1, 2, 3, 4, 5. How many into the 3D do I need to get to cobalt? 7. Okay, so 1, 2, 3, 4, 5, 6, 7, and I'm done. Okay, see how I did that? Slowly. Follow the numbers and it will take you right through the areas. Okay, if you don't follow the numbers, you're not going to make it. Okay, we okay to go forward? We do need to make sure that we're showing each of these orbits. I can't just go like this and say, oh, there's just 1 in the 2p. That's not right. Okay, so I do need to show the orbits. If you want to do it like this, they have done it like that, and you can do it like that. That's okay. But you do need to show it as 3 separate rooms or 3 separate orbits. Okay, you have 2. I want you to try on your own. Magnesium and chlorine. So try them on your own real quickly, and then we'll go on to the electron configuration and then the noble gas. So this is the hardest level because it shows everything. And then we're going to shorten it up. Okay, if you're having problems, let me know. I'll come around and help. Always start at 1, the 1s. Okay, come on, guys, let's go. 1s. Starting up with the 1s. You're going for manganese, and manganese is number 12. So magnesium is number 12. Manganese is not the one we're looking for. So magnesium is in what?
Can I get help?
Yeah.
I don't get this at all.
Okay, so these are S, P, D, and F. Okay, the numbers we put on are the shells out from the nucleus. So we're looking for manganese, which is number 12. So we're going to start up here at number 1, and we have to go through all of them to get to number 12. So the first one is 1.
2, 3, and then you count.
Right, so we say, okay, we're on the first row, we're in the S, it's going to have 1 room. So 1S with a line above it.
And then
and then arrow up for hydrogen, arrow down for helium. Then you're getting to the second row in the S, and there's one room. And lithium and beryllium. Now go across. Now we're in the what?
Wait, where am I right here?
So you're right here. Now you got to come across. Now you're in the what?
I'm at 3P.
Nope, up 2P. 2P. How many
why
rooms?
split?
You got to count the numbers. 4,
Oh, wait, I was right here.
5. Yep.
I thought we were at 12.
No.
5.
So you're at the 2P. How many rooms?
2P.
P equals 3. So you're going to have 3 rooms above it.
So, 2, 3.
And you're going to go all the way through. So put one room, one arrow in each one, then go back and pair it.
Like that.
Okay, and then you're not there yet. You're at number 10, so you still have to get to 12, so you keep going. So then you come down to the third row. You hit the S, so,
3S.
and there's one orbit. And you go up for sodium and down for magnesium. And you're done.
Got it.
Got it? So now try it
Pretty
for the
much
next
just
one,
count
chlorine.
and Put these arrows.
Right, but you need to know how many, so on this one when you got here, instead of putting 2P right here, it's actually in the middle of the 2P because this whole thing is 2P. Does that make
All right,
sense?
I think I.
Okay, so now do chlorine. Okay, I'm going to put the answer up here on the board. If you haven't got it, put it down. And then hopefully you'll be able to get it. So magnesium is number 12 right here. So we're going to have 12 arrows by the time we're done. We always start at the top. So we're going to start in the 1s. It has one orbit. Hydrogen goes in, helium goes in. Then we come down to the second row. We are at lithium. It's in the 2s, one orbit, up for lithium, down for beryllium. Going across, we hit boron. Boron's in the 2p. 2p has 3 rooms. And we're going all the way through it. So we're going to go all the way through the 6 and come out over here. So we're going to go 1, 2, 3, back and pair it, 4, 5, 6. We hit the third row. We hit the S. We have 1 room, sodium, and magnesium, and done. Chlorine's going to be the same thing because it's a little past magnesium. So if we do what we had for magnesium, so 1s, 2s, 2p, 3s, so we're right back to where we were at magnesium. We're going to go a little bit farther to get to chlorine. So we hit the 3p. 3p has 3 rooms, and we're 1, 2, 3, 4, 5 into it. So 1, 2, 3, 4, 5. Okay? How are we doing? Thumbs up, I understand this. Thumbs down, I do not. Thumbs sideways, I'm sort of getting it. Okay, so if you're thumbs up and you're by a thumbs down or thumbs sideways, please help them. Because sometimes explaining it from a peer rather than a teacher, because I teach it one way, you might explain it a different way and that might help them. So please help them. Okay, you got some more. Did we just do magnesium and chlorine? Yes, we did. We just did that. Okay, so now we're going on a shortcut. Everybody likes shortcuts, right?
I love shortcuts.
Because think about doing this arrow one for like platinum down at the bottom or like uranium. That's a lot of arrows. 92 arrows, I'm going to get really tired of doing arrows. But the nice thing about the orbital notation, it tells me where every electron is, what shape the orbit's in, how much I have in each one. It'll also tell me if it's magnetic or not. So when I get to the end and there's a lot of arrows that are up and no arrows down, we call that paramagnetic. And that's what iron is. And that's why iron has magnetic properties, is because it has these unshared pairs of electrons. Okay? So if it's diamagnetic, where it has an up and a down, then it's not magnetic. It doesn't connect things. Okay? So here's the shortcut. Nitrogen. Everybody find nitrogen.
Found it.
Got it? Okay, this one is in your packet, so you're doing it with me. We are going to write down what we see. We're not going to put the arrows again because we know the first arrow is an up, we know the second arrow is a down, and so we're going to condense that amount. So instead, we're still going to start up at the top and say, oh, we have to start on the 1 in the S, But we know that there's 2 that we have to go through there. Okay, so hydrogen and helium. I just counted for them. Now I'm on the second row. Second row, I hit the S. How many do I have to go through? 2. Second row, I hit the P. How many do I have to go through? Done. Okay. Let's do yttrium. Ooh, that's a big one. Okay, here's yttrium. Ready? We're doing the same thing at first, right? Follow with your finger, and that will help you. So I always follow with my left finger because I'm right-handed. If you're left-handed, follow with your right finger. And I just follow the periodic table as I go. So we know we're going to be like nitrogen at least, so I'm going to get that far. But instead of 2p3, we're going to go all the way through the P, right? So 2p, 6, then I hit the third row, and I go through the S, and how many do I go through? 2. And then, following across, I hit the 3p, good. How many am I going to go through? 6, good. And then I hit the 4s, by the way, that's a 6. 4s, and how many am I going to go through? 2. And then I hit the 3d, and how many am I going to go through? 10. All the way across is 10. Good. And then I hit the, what do I hit next? 4p. And how many am I going to go through? 6. All the way across. Good. And then I hit the 5s. How many am I going to go through? 2. And then I hit the 4d, and I go through 1. And I do have to write the 1. So it's not like math when there's a 1, I just drop it. I'm telling how many's in it. Okay, you got a couple to practice. See if you can get your practice done. Let's see.
Why do your S's look like 5s?
I don't know, I'm sorry.
What doesn't her S's look like? What don't her S's look like?
Like, I was writing them down, she's like, where'd you get the 5?
If you don't know what phosphorus is, it's over in the pink area. So see what you can do. I'm going to rush you through this a little bit. So if you don't get these ones done, because there's 4 of them, I am going to put the answers on the board so we can rush through them, and you can stop it on the video if you want to see it. So don't look up unless you've got it done and you want to check, because I'm just going to rush through them. If you're watching this on the video and you go back and look and see if you got it right, you can pause it. Okay? I'm running out of time. And I want to make sure you get the other part that you need. Okay, I'm going to rush you forward. So finish those so you can check them. I did put them on the board so that you could see them later. They will be up on Canvas. So flip to the next page. We're going to talk about noble gas configuration. There's even a shorter way, which we love, which is noble gas configuration. Where are my noble gases? They're on the very end. So if this was my electron configuration, okay, to shorten it, I play the prices right. What noble gas is closest to without going over the price of my element? So, or the number of protons in my element. So, 5d9 is right here, right? 5d9 is gold. So, gold has an atomic number of 79. So I look at the noble gases and find that xenon is the one that is closest to without going over at 54, because this one, which is radon, is 86, which would be over, and I would lose the Price is Right. Right? Price is Right. You have to be lower. You have to be lower. So what I say is, okay, gold is like xenon, and I just start doing the electron configuration from xenon. So I put xenon in brackets, and I go 6s2, 5d, or sorry, I got to go down, 4f14, and then back up to 5d9. But the one thing with noble gas configuration, I want to write it this way while I'm writing it down, but then I have to change it. And the reason I have to change it is noble gas configuration is written so I know what electrons are going to react with other chemicals. And that's the outermost shell, not the innermost shell, but the outermost shell. Whoever I bump onto, that's going to be the electrons that react. So I rearrange this. I still say it's xenon, but I rearrange it according to the shell out. So I would put 4f14, and my thing's not writing real great, 5d9, and 6s2. So the 6s2, 2 electrons in the very outer shell are the ones that are going to react. Okay, so let's try it. This is not hard. So find aluminum. Okay, got it? What's the noble gas closest to without going over aluminum?
Neon.
Neon. Okay, so we put neon in brackets. Okay, I am at neon. Okay, I'm coming down here and I say, what else does it need? At the third level, in the S, it needs 2. In the third level, in the P, it needs 1. Both of these are 3s. I do not have to rearrange it. I'm done. Okay, let's do the next one. That's it. Protactinium. Ooh, this one's down the bottom. 91.
Also, would it be just like
What one's closest to without going over 91 for the noble gases? Rn. Okay, so we put Rn in brackets, and we start from Rn. So we then go, because Rn is right here, so we start there, we come down the 7th row. 7s2, then I got to come down here to 5f, how many in? 3. These are not the same, I have to reorder them. So I reorder them by saying, okay, it's like radon, but in the 5th level out, in the F, I have 3, but in the 7th level out, in the S, I have 2. These right here are the ones that are going to react in a chemical reaction. So I want them on the outside. Okay, bismuth. Let's see if you can do it faster than I can. Noble gas, closest to without going over. Xenon. Okay. And start from xenon, going forward. Xenon is right here. So we're starting right here to get over to there. We go 6s2. Then we got to come down to here. 4f14. Then we come back over here following the numbers, and we come back up here. Whoops, right here. It's 5d10 and 6p3, right? But these are different numbers, so I've got to rearrange them. Okay, so xenon, bracket, 4f14, 5, that's a funky 5, d, 10, 6s, because I went all the way through this. 6s2 and 6p3, and that is my answer. Okay, easy, once you get that stage, right? Okay, you have a couple practices that I'm not going to have time to do them with you, but then you have practice that you're practicing this. Sorry we did not get to it in class. You're going to need to do it on your own. Yes?
Do we have to do this way, or can we?
You need to do it each way. So if I ask you for orbital notations, I'm asking for the arrows. If I ask you for electron configuration, it's 1s2 all the way through. If I ask you for noble gas, it's this way. Each one has a specific need and way we're going to use it later.
When you ask us to label it, we don't have to do all 3, though. It's just
No, just the one that I'm telling you to do. Okay? All right, so I think this next part is just, I will really quickly put that up at the end. And then your work today is your daily work, practicing on your own. Okay, so I will do this one really quickly. Sulfur, noble gas, closest to without going over, neon. And 3s2, 3p4. Nickel, closest to without going over is argon. Then it goes 4s2, 3d. How many are we in? 8. Rearranges because these are not the same. Argon, 3d8, 4s2, and done. And that's the rest of your notes.
No, it's already not in the right order.
Okay, this is a great question. He asked, if I know it's already not going to be in the right order, can I just rearrange it as I'm doing it? You can, but 90% of the kids that do that do it wrong. So what I would suggest is just write it down as you get it off the periodic table. Once you get it written down, it's real fast and easy to rearrange. Then you don't make a mistake. Yes, ma'am?
Why do you have to rearrange them?
Because I want the ones that are the farthest out on the very last, because those are the ones that are going to react. And those are the ones I'm working with. So that's what the noble gas configuration is all about. I want the outermost ones. When I bump into an atom into another atom, what are the outermost electrons that are going to react? They might not be the last one I'm filling. It's like this one. The last one I was filling was 3D, which was one in from the 4th level. Do you see what I'm saying?
Sure, yeah.
Okay. All right, so you guys have a few to practice at home. Please make sure, like neon up here is a capital E, capital N, capital E. That's wrong. Remember, capital first letter, lowercase second letter, okay? For noble gases. All right, so you do have a little bit of homework. I'm sorry. There might be a little bit of time next time. I don't think we're as rushed next time, I'm hoping. So you got to color. Make sure your coloring crayons get put back. Thank you.